Okay, FST students, today we're going to take a look at how to find what's called a standard deviation. So if you go to the post on standard deviation, today we're going to take a look at this. So we're going to look at what's called measure of dispersion. There are two tools that we use to describe the spread of the data, which is obviously dispersion. And the two tools are range, which we've talked about that before, and the new one for today is standard deviation. Range, you guys know, is the difference between the highest and the lowest data value in a data set. An example I have here for you is the oldest Oscar award-winning actress was 82, the youngest was 22. The range is obviously 82 minus 22, which is 60, right? So I came down here with another example looking at ages of cats in a given animal shelter, 1 being the minimum, and if we look across here, 12 is our largest, so 12 minus 1 is obviously 11. So what is standard deviation? Standard deviation describes how much each data item differs from the mean. So what we're going to do here, these are the steps in order to calculate it. We're going to do that by hand today. So this symbol right here, when you get to the fourth step, stands for sum. It's a Greek symbol, sigma. And then down here, as we go through, then we're going to end up taking the square root of the whole deal. So the other sheet that I have is this guy right here. I'm going to have you guys fill this out. I already pre-did it, so I don't use up too much time here videoing. So this is the data that we're going to use today. This is looking at the number of cases of coronavirus in the counties of Ohio. This was done probably about over 4 days ago. So obviously things have changed now. I didn't look at it today as to what it is, but sure it'd be nice if things were down lower, right? So this is the number of people that are affected. And down here I have Medina County. So as of this date, like I said, about a couple of days ago, this is that we were at 74. So we're going to take this column only, and we're going to transfer it right in here. So I wrote it, or typed it, I should say, all in this column. So you want to do the same, follow along as to how I'm doing this. Okay. Now the next thing we're going to do is we're going to find the mean. Now right away you will see 203.3, but how do we get that? So what you do is you want to go to your calculator here, L1, you want to type in all the values right here in L1 from this column, right? So we're going to do that. So you will see that I typed all those numbers in, and I want you guys to do the same because you're going to be asked to do this on your own. Then we're going to go to Stat, Calculate. You're going to see one variable stat. We're going to press Enter, and then we're going to tell it that we want it to look at L1, so second one. Press Enter, and this X with the bar on the top stands for the mean. So that number goes right here. I did 203.3 is what I did. Okay, now we're going to go back to Stat, Edit, and then in L2, what we're going to do is this here. It's going to be L1 minus the mean. So we're going to come over here, we're going to highlight it, and it's going to be second one minus the mean, which is 203.3. I hit Enter, and there's my numbers there. And if you notice over here, I wrote all the numbers in this column. Okay. Then we're going to go to L3. L3, if you take a look at it, is L2 squared. So we're going to take these numbers here, and we're going to square them. So in my calculator, I come over here, I highlight L3, I go second 2 squared, here it is right here, and I press Enter, okay? And by the way, I'm taking a look at it, data item minus the mean is what's called a deviation, right? How far does each data item deviate from the mean? Then we're going to do deviation squared, so that's these numbers right here. Okay, L4 is going to be the cumulative sum of L3, because what we want to do is we want to add up all these numbers in L3. We want to take that total sum and we want to put that number right here and see what we get. So we're going to come over here, we're going to highlight L4, And we're going to do second stat ops and come down here to cumulative sum. I think we did this before with something earlier. So cumulative sum, I want to do the cumulative sum of L3. Press enter. There's our number. Now what we want to do, we want to get the very, very last number because that's the cumulative sum of all these numbers. So let's see what it is because I don't know what it is as of right now. So here we go. So that number, I'm going to click on it. It is 611,927.35. So that number is going to go right here, 611,927.35. So that is our cumulative sum. Okay, so what do we do with that? So the next thing we're going to do is we're going to take 611,927.35 and we're going to divide it by the number of data items we have minus 1, which I believe the number of data items we have is 16, right? There's 15, I guess we got 15. I guess it's 15 data items that we have here. So what we're going to do is we're going to go 15 minus 1, which is obviously 14. So we're going to take this number, second quit right there. What we're going to do, we're going to take the square root of 611,927.35 divided by 15 minus 1, which is 14, right? And close that off. And let's see what we get. What is our number? Our number is 209.067. That, my friends, is the standard deviation, and it's abbreviated SX. That's the symbol we use for standard deviation, and it is 209.067. So that's the standard deviation, okay? Now, let's check and see if we did this correct. So what we're going to do now, we're going to go to stat, and we're going to go to calculate. We're going to go to our one variable again. We're going to look at L1, and we're going to press enter. Now, I want you to look at this. The mean was 203.3. I'm going to scroll down here and take a look at this. SX, right? Standard deviation, and check that out. 209.067. That's exactly what we came up with when we did this by hand. Okay, so that's how we find what's called standard deviation, all right? And eventually what we're going to do is we're going to take and graph this out eventually in another day here. Medina is at 74, and our standard deviation is at 209.067. So what does that all mean? Well, in a couple of days or so, we will find out exactly where does Medina compare to all these other counties. Now, mind you, we only went out to Montgomery. We did not do all of these. So what would be really cool is if we take and put all this data in, which we will do that eventually. We're going to put all this data in, and we're going to actually see how Medina really does compare with all the counties in the state of Ohio. Okay, so that's what we're going to do today, and I want you to work on finding the standard deviation.